Okay, students, let's continue. And our next question is about the breadth first search or BFS. Okay, so for the BFS, and we start from a graph below. And by the way, this is exactly the same graph. So this is suggested by one of our students, and she said, how about we just use the same graph if possible, to show as many algorithms as possible. In this way, we are not distracted by different of the representations. We are using the same graph and solve different problems. I find this is a terrific idea, and this is the reason you are seeing this graph again and again and again. And by the way, I did do one small change because now all the nodes are in the white color because we are doing the BFS, and the colors of the nodes, they mean something. They all started as white. Okay, and we are going to do a BFS, and we start from the node 0, and then here are some of the things I want you to show. Well, the sequence of the nodes visited in queue. Oh, and by the way, you do have to take a look on the algorithm. There's a queue inside of the BFS, and then and also the D and the pi. And what do they mean? The D means the distance between the current node we are touching to the node which is the source, the starting point. In our problem, we are starting from the node 0. And for example, if you're the 5, and from 5 to 0, there is 1, 2, and 3. So as we are doing the eyeballing, it seems that the shortest path from 5 to 0 will be 3, right? So the D will be the D for the node 5 will be a 3. And how about pi? And the pi will tell you if from the 5 we are going one step closer to the source node, which is 0, which way should we go? From 5, we can go to 2, we can go to 6. But if we are trying to go from 5 to the source, which is 0, we definitely want to take the 2. So 2 will be the parent, or the pi, for 5. Okay, so you can, and in addition, I say you can assume that the graph is represented in an adjacency list, and all the adjacent nodes are pre-sorted from low to high using their indexes. Okay, so this will solve a lot of the problem. Let me go to my drawing board. Come on. Okay, here. So we are going to start from 0 guaranteed, right? So at the beginning, when we start from the 0, and then we are going to change the color to, come on. We are going to change the color to gray. So it will be a gray node. And after that, what we are going to do is we are going to send all the adjacency nodes from the 0 into the queue. So we have 1, we have 3, and we have 8. And which one will be sent to the queue first? And remember, we are assuming that we are doing an adjacency list, and then all the nodes are pre-sorted from low to high. So we are going to have 1 in the queue, and then 3, and then 8. So that is guaranteed, right? Because, well, from the 0, and then the adjacent nodes are sorted from low to high, so 1, and then 3, and then 8. Okay, and after that, and there's really nothing to do for the 0. So now 0 will be black, saying we have already touched that. And meanwhile, we are going to have 1 as gray, 3 as gray, and then 8 as gray, and that is to say, well, we have finished. We are touching 1, 3, and 8. We are not finished yet, but they are already discovered. Okay, and then we are going to move on, and then we are going to touch the 1. So for the 1, we are going to discover the adjacent nodes, and we have 7. So 7 will be okay. So let me do the pi and the d. So let me start from the 0. So for the 0, the d will be a 0 because the distance between 0 to itself is a 0, and then the pi, which is the parent, will be a nil because, well, it can go from itself to itself. There's no parent. And for the 1 and 3 and 8, the distance will be 1 because they are directly connected to the source node, which is 0. So 1 and 3 and 8. So they should be okay. There should be a 1 here. Excuse me. Okay, so it should be a 1 and a 1 again. And then the parent will be a 0, and a 0, saying, well, from 1 and 3 and 8, the distance between those three nodes to the source will be a 1. And how do you go there? And you just go there by going to the node 0, and then you will go to the source, which is also 0. Okay, and then let's touch the 1 again. So now we are touching the node 1. And for the node 1, and we are going to discover 7. So 7 will be added to the queue. And then for the 7, the distance will be the distance of the 1 plus another 1. So the distance between 7 to the source will be a 2. And how does 7 go to the source? We are going to go from the node 1. So this means 7 has also been discovered. So it is a green node now. And then for the node 1, there's nothing more to be done or to be discovered. So I'm going to say now 1, you are black. So let me cross that out. Okay, and then the next node we are visiting will be 3. And for the 3, we are going to be able to discover both 2 and 4. So both 2 and 4, the distance will be the distance of 3 plus another 1. So distance of the 3 will be 1. So for the distance of the 2 and 4, they will be 2 and 2. And how do you get there? You are going to get to the source from the 2 and 4 by going to 3 first. So for the parent of the both 2 and 4, they should be 3. So after that, there's nothing more to be done on the 3. So 3 will be black. And meanwhile, the 2 and 4 will be added to the queue. And both of them will be gray for now. Okay, and then we have already done the 3, so let me cross out 3, and now 8. So 8, when we are touching 8, and we will see 8 connects to the 4. But do we want to add the 4 to the queue again? The answer is no. Why? Because the 4 is already gray. A gray means this node has already been discovered, but we haven't really fully explored that yet. So for the 8, actually there's nothing to be added, and I'm gonna simply change the color to black. So 8 is already done. There's nothing to be updated here. And the next one, we will go to 7. And for the 7, we will explore, we can see 2, but 2 is already great. So there's nothing to be done as well. There's no additional node we want to add to the queue. So 7, I'm gonna change you to black. And then let me cross the 7 out. The next node we are visiting is 2. And for the 2, we see, okay, there is a white node which is 5. So this means for the 5, the distance will be the distance of 2 plus another 1. So the distance of node 2 is 2, and plus 1 we will have a 3. And then who should be the parent of 5? It should be the 2. Because from 2 we discovered 5, so the parent of the 5 will be a 2. And in this case, and there's nothing more to be done for the node 2, you are blacked. And then for the 5, you are now in a green node. And I also need to write the 5 to our queue. And after doing that, 2 is finished. I want to cross that out. Okay, the next node will be 4, and for 4, nothing to be done, nothing will be added, so 4, you are done. And how about 5? So from 5, we will discover 6 as another white. So we are going to enqueue the 6. And then for the 5, there's nothing more to be done. And then I'm going to change the 6 to gray. And then for 5, we have already fully explored you. And then I'm going to cross the 5. And for the 6, the distance of 6 will be the distance of 5 plus 1. And so distance of 5 is 3. So the distance of the 6 will be a 4. And the parent will be 5. And eventually the last node will be 6. And for 6, there's nothing more to be done. So I'm going to color that into black. And then, ta-da, our work is finished. Okay, so to answer the question I just showed you, let me bring back my PowerPoint. Okay, so the sequence of the nodes visited in the queue, and then we do have the history of the queue 1, 3, 8, 7, 2, 4, 5, and 6. Those are the sequence of the nodes we are visiting in using the queue. And another thing we are asking for is the d, which is distance, and the pi, and we also have those two. Okay, and in our course lecture PowerPoint, we did this. So for the 1, it goes to 0. And then for the 2, it goes to 3. So what I'm doing is I'm coloring all the parent the edges from a parent to a node to its parent in the red color. Okay, so and then for the 3 goes to 0. And then for node 4 goes to node 3. And then for node 5 goes to node 2. And then for node 6 goes to node 5. And then for node 7 goes to node 1. And then for the node 8 goes to node 0. Okay, so well, in our lecture notes, we did this way, and we just highlight the edges from a node to its parent, and it will give us the tree structure. But if in reality, when we are tracing the algorithm, we don't really use the red color. The red color in my lecture notes is really more for the illustration purpose, and in our solution, we are using the pi here. If we highlight all the edges between the node and its parent, and then those are all the red edges. Those are the edges between a node to its parent. Okay, so if you highlight all those colors in the red, and then you will see the tree structure using the 0 or the source node to all the nodes. Okay, so this is the video of the BFS, and I will see you in the next video. Bye.